If inside a transaction, a piece of Bitcoin is being spent, for example, Alice is sending some Bitcoin to Bob, then that piece of Bitcoin cannot be referenced by another transaction again. As soon as a transaction is confirmed, you cannot spend the Bitcoin again. So which brings us back to the initial situation that we had. We have Alice that is trying to spend the same Bitcoin twice. Therefore, we have two transactions on the network referencing the same Bitcoin. As soon as a Bitcoin miner is going to mine a transaction that contains either Bob's or Jane's transaction, then the other transaction is going to be rejected. For example, if this is the first transaction to be included in a block by a miner, then the second transaction is going to be rejected by the network. If this is the first transaction to be included in a block, then this one is going to be rejected. You cannot spend the same Bitcoin twice. And that's what Bitcoin mining is really for. It prevents people from double spending the same Bitcoin. And if we take a look into our wallet, we can right click on any of the transactions that we have previously and click on View on Block Explorer. This is our address where we were transferring from Bitcoin from the exchange to our wallet. And over here, you can see that it is included in the following block. So if I click on here, I can see this is the block where the transaction is included in. Down here, if you go to details, you can see the version, you can see the Merkle root of that block, you can see the nonce value. These are all encoded, so you have to decode that to have a real number, and so on. And down here, you have all the transactions that were included in that block. You can see that in that block, we had almost 1,400 transactions. You can see that there's a total fee because a transaction also always have a fee. So Bitcoin miners will almost never proceed a transaction without fees because mining Bitcoin is energy intensive. They have to be paid for that. That's why in a transaction we have a fee. And this also prevents people from spamming the network with transactions. So you see the hash of the block, the timestamp, the size of the block, and much more information. You will also see which miner was able to mine this block. So now let's see what happens with the block after a block was mined. So this is our Bitcoin miner and he successfully mined the following block. What happens next is that this Bitcoin miner is then going to broadcast that block to the network. So in our case, our Bitcoin miner might be connected to this full node. So it's going to send that block to the following node. The node is then going to take the block and verifies it. It will check if the block hash provided by the Bitcoin miner is really below the current network target. If that's the case, that means it's a valid block. And also check if all transactions inside the block are valid transactions. In general, the node will then check if all information in the block header are correct. And if that's the case, it's then going to add that block to its own local copy of the blockchain. And next, this node is then going to forward that block to its peers. And this is just how a block is propagated through the network. So in our case, the Bitcoin miner over here create a block, send the block to a node. The node validates the block. If it is valid, the block is forwarded to the other nodes on the network. And as soon as a block is received, all the transactions inside the block are removed from the memory pool because from that point on, the transactions are considered valid. If a miner is building a block, for example, on top of this one, and then receive this block, then he must stop working on the previous block and start working on top of this one. So he will take this block hash and reference it in the new candidate block instead of this one.